Hello, math students. Welcome to our new module called Area, Surface Area, and Volume Problems. This is lesson 1, and it is called Area of Polygons. Our goal for today is, we will learn how to use the area knowledge to find the areas of many shapes. The question that I want you to be thinking about is, what area do you use to find the areas of other shapes? All right, so we're going to start off today's lesson with some things to remember. How do you find the area of shapes? What is area? Is there anything specific that you must remember when working with area? All right, so how do you find the area of shapes? The way you find the area of shapes is you figure out what is the space inside a given shape. So how to find the area of shapes is you must determine the size of the amount inside a shape. Okay, and we do that several different ways. If you're thinking about rectangles, then you would take the length times the width, because the length times the width are the dimensions of the rectangle, and that gives you the amount of space on the inside of the rectangle. So what is area? Area is the amount of space inside a shape. Okay. Is there anything specific you must remember when working with area? I would definitely say yes. You need to know dimensions of the shape. And when I'm talking about dimensions, dimensions are the sizes. Okay, so that's very important. All right, so the first thing that we need to talk about, and I'm hoping for all of you that this is a review, but the first thing I want to talk about is finding area of a rectangle. Okay, so I did mention that a little bit ago, that when you find the area of the rectangle, you take the length times the width. So to find the area of a rectangle, this is the way we would write it. Area of rectangle equals length times width. Okay, so now we're going to extend that to our next shape that we want to look at. And what you need to do with a parallelogram is actually the same thing as a rectangle, because what we're going to do, I'm going to show you this, is a parallelogram is actually a rectangle that's been pushed on one of its corners and made to slant. Okay, so it's actually a slanted rectangle. So if I was to drop a vertical line that's perpendicular to the top and bottom of this rectangle, if I was to cut this edge off and I take this guy and move it over here, then what you see is what shape? What shape do you now see between the orange sections? And if you said a rectangle, then you are correct. So a parallelogram literally is just a rectangle that has been squashed. So how do you find the area of a rectangle? Length times width. Well, a parallelogram is no different. The way you find the area of a parallelogram is length times width. Okay, so that's pretty cool, isn't it? Because we just proved that that's all a parallelogram is, that somebody took their finger and squished the parallelogram and it shifted. Okay, so area for a parallelogram is exactly as the area of the rectangle, exactly the same. Okay, so then the next one that I want to talk about is, how do you find the area of a right triangle? Well, the thing that's really cool about right triangles is right triangles are actually formed by taking a rectangle and cutting it diagonally from corner to corner. And if you cut a rectangle diagonally from corner to corner, then you come up with a right triangle. And so in order to find the area of a right triangle, or any triangle for that matter, you have to take the length times the width, because that's a rectangle, and then we cut it in half, so we need to divide it by 2. So you take the length times the width and then divide it by 2. Because a right triangle actually was a rectangle cut from corner to corner diagonally, and then you end up with 2 triangles. So we have to divide it by 2 because we only want 1. So you take the length times the width and then you divide by 2. That's how you find the area of a right triangle. Okay? So those, I'm not too sure of what was actually new information for you on this one. I know that you already knew the area of a rectangle because I've asked you that many times and you already knew the answer. So the area of a parallelogram might be new, but is it actually any new information? Nope, you're still doing length times width. And then right triangle, you're still doing length times width, but this time you're dividing it by 2 because there's 2 triangles in every one rectangle. Okay, so that's kind of good information. Now let's look at what we do if we have a trapezoid. If we have a trapezoid, what I want you to think about is there's actually 2 different ways to determine how to build a trapezoid. And what you have to think about with a trapezoid is that you actually, if you take this little guy right here, just like we did with the parallelogram, and we cut it off, right? And then if we take this little guy right here and we cut it off, what shape do you see inside here? You do. You see a rectangle and 2 itty-bitty triangles. So for a trapezoid, to find the area, you can do it 2 ways. You can figure out the area of a rectangle, so it would be a rectangle, and then it would be plus a triangle, plus a triangle, and that's how you would find the area of the trapezoid. Now, the only thing that makes that difficult sometimes is they don't always give you the distance from here to here and from here to here. So this way, technically you can find it as long as you're given the dimensions. However, if you're not, there's another way that you can find the area of a trapezoid. And the area of a trapezoid is like this. So area of trapezoid equals, you're going to take base 1 plus base 2, divide it by 2, and then times it by the height. Okay? And now let me label that for you. So base 1 is going to be one of the bases, either the top or the bottom, it doesn't matter. Base 2 would be the other one. And then you're going to divide that by 2, and then you're going to multiply it by the height. And the height is the distance from the top to the bottom of the trapezoid. So let me say it again. You're going to take base 1 plus base 2, divide that by 2, and then times it by the height. That's how you find the area of a trapezoid. Okay? So then the last thing that we need to cover, because you already know how to find a rectangle, how to find a parallelogram, how to find a right triangle, how to find a trapezoid. Now the last one that I want to talk about is composite figures. Composite figures are actually figures that are built by adding a whole bunch of figures together. So a composite figure means that you have one or more figures put together. So this one alone has some very interesting ones because I see a rectangle right here, and then this is an octagon. But you haven't been taught how to find octagons, but you have been taught how to find trapezoids and rectangles. So look at what happens when I draw a line from this corner to this corner. What shape do you see? Trapezoid. When I draw a line from this corner to this corner, what shape do you see? Trapezoid. So this is a trapezoid, you would use this formula. This is a trapezoid, you would use this formula. This is a rectangle, length times width. This is a rectangle, length times width, and then you're going to add them all together. So to find the area for this composite figure is you would go area of all of these, area of rectangle, right, plus an area of a trapezoid, plus an area of a rectangle, plus an area of a trapezoid. And then once you add those all together, then you will get the area of this entire composite figure. So that's how you find the area of the composite figure, is you break it up into the smaller shapes that you can see or that you can find, and then you add them all together, and that would be the area of your composite figure. Okay? All right, so down underneath here, I have listed some very important formulas for you, and it says formulas for finding area. Area of a rectangle is length times width. Area of a parallelogram is length times width. Area of a triangle is base times height, which is the same as length times width, times 1/2, which is the same as divided by 2, right? Area of a trapezoid is base 1 plus base 2 divided by 2 times the height, which is what we set up there. And then area of a composite figure, you take all the areas of all the shapes used to make the composite figure and you add them together, which is what we did up there. Okay? So this is just another way to see it all in a short little list. So now your job is to try, using all of this information up here, to figure out what is the total area of this guy. Okay? You're given dimensions, the width, the length. Okay, I see a shape. If you were to just draw something right here, there's one shape, right? If I drew something right here, then I would have another shape right here, and then I have the third shape right here. So you're lucky in this composite figure, the only shapes that you have to worry about are rectangles. So I'm not going to help you with it. I want you to try it by yourself. I'm really sure that you can do it, and we will see when we check your notes in tomorrow. Okay? So, kind of a fun lesson, talking about finding area. Oh, there's one thing I forgot to mention, is that whenever you are working to find area, the most important thing to remember when finding area is that your units of measure are always going to be squared. Because when you're finding area, area is when you multiply two things together. I multiplied two things, 1, 2. 1, 2, 1, 2, 1, 2. So you can see that in every single one of these, trying to find the area, you're multiplying two dimensions together. Length times width, base times height. Then you're going to find the base times the height. So it's two things that are being multiplied together. So since it's two things that are multiplying together, your units of measure have to say whatever they are squared. So the answer for this composite figure, the area better be whatever it is, meters squared. Okay, you have to put meters squared because area is squared. Volume is cubed, area is squared. Volume is cubed, area is squared. Okay, so you need to remember area is squared. So all of your units of measure have to have the little 2 for squared. Okay, so let's go back to our goal. Today we will learn how to use the area knowledge to find the areas of many shapes, which we did. What area do you use to find the areas of other shapes? And I think we could successfully say we use the area of a rectangle to find a lot of other areas, because the area of the rectangle is length times width. And in almost every one of our problems, we did length times width. Okay? All right, kiddos, that's all I have for you in this lesson. I'll talk to you soon. Bye!